Hello and good morning. Once again, I welcome you on the lecture series of course Elements of Machine Design. Today we are in lecture number 5 of chapter Selection of Anti-Friction Bearing in Gears. In this chapter, up to this lecture, we have seen the introduction to the anti-friction bearings, classification of anti-friction bearings, what is the function of bearing, what are the applications of the different types of the bearings, basic terminology associated with the bearings, what are the basic terms, that is the static equivalent load, dynamic equivalent load, life of the bearing, dynamic equivalent load. In next lecture we have seen the properties of the bearing materials and which are the materials that are used for the manufacturing of the bearings that will act as the bearing materials, and what are the requirement of the bearing materials. After that we have undergone the selection procedure of bearing from the manufacturer's catalog. That means how to select a particular bearing from the manufacturer's catalog. We have seen the different steps, step-by-step procedure to select the bearing from the manufacturer's catalog. So up to this lecture number 4, we have completed the topic regarding the anti-friction bearings. Now we are moving to the next part, B part of this topic, that is the gears. Now our study is restricted to the spur gear, so we will discuss about the spur gearing. So let's start with the basic information regarding the gear. What is meant by the gear and what is meant by the spur gear? So as we know that the gears are used for the transmission of powers. Means gear transmit the power for a shorter distance. There are different power transmission elements that we are using, that is belts, ropes, shafts and chains, and another mechanism that we are using for the transmission of power between the small distances, that we are using as the gears, that is known as the gear drive, which is used for the transmission of power from the one point to the another point. So gear is nothing but a power transmission element which is used for the transmission of power for a smaller distance. We are using belt and rope in a common applications when the transmission of motion of power between the two shafts. Now the effect of slipping is to reduce the velocity ratio of the system. Due to the use of belts and ropes, there is a chances of slipping, that you have studied this concept in the subject theory of machines. In precision machines, where we need to transmit an exact velocity ratio, where we have to transmit the exact power between the two mechanisms, then we have to go for the gear drives. That is also known as the toothed wheels. A gear drive is provided when the distance between the driver and the follower is very small. This is the driver and this is the follower, and it is a toothed wheel, means teeth are provided on the wheel. That's why it is known as the toothed wheel. These are the teeth, these are the two shafts in between which we have to transmit the power. This is the driver which is actually driving the gear, and this is the follower. So from this gear we are transmitting the power to this shaft, and by this shaft we are transmitting power to the another mechanism. So gears are nothing but a toothed wheels. The teeth are provided on the circular wheels. That's why it is known as the toothed wheels, which are used for the transmission of power between the two shafts when the distance between the shafts is less. And the major importance of using gear for the power transmission is the definite velocity ratio. That is the velocity transferred by one gear to the another gear. So this is the importance of using gears for the transmission of power between the two shafts having the shortest distance to provide the exact velocity ratio. So let's see the advantages of the gear drives over the belt drives, rope drives and shafts. Why we are preferring the gear drives? Why we are preferring the gears for the transmission of power? The first advantage is it transmits exact velocity ratio. It is velocity of the driver to the velocity of the driven. We can calculate the velocity ratio by calculating the number of teeth on the tooth wheels. So if we want to transmit the exact velocity ratio, then it is possible only by using the gear as a power transmission element. The gears can also be used for the transmission of large power. If we want to transmit a large power between the small distances, then we can transmit the large power by engaging different types of gear, or by engaging n number of gears. We can transmit this large power from one shaft to the another shaft. It is used for the small center distances of shafts. When the distance between the two elements in which we have to transmit the power is very tiny. Take the example of the wristwatches. In that case, gears are used. We know that the gears are used in the wristwatches for the power transmission. It has high efficiency as there is no chances of slipping. So as compared to the belts and ropes, we can transmit the power by using gear with a greater efficiency. It is a reliable service. Any design engineer can rely on the capacity of the power transmission by gears, and it has a compact layout as the distance between the two shafts is small. It is not having a larger distance, so it has the compact construction. We can accommodate a gear in a particular casing, or it will be easy for the having the simple and compact construction when at the time of the maintenance. So apart from these advantages, it has some disadvantages if we are using gear as a power transmission elements. The first disadvantage is since the manufacture of gears requires special tools and equipments, therefore it is costly than the other drives. As the power transmission is very precision, as we are getting the exact velocity ratio, as the efficiency of the gear transmission is very good in case of the gears, power transmission is very good in terms of gears. So we need to manufacture a gear with a precise control, with a precise dimensions. So this is the one of the disadvantage, that we require the costlier machines, experienced workers and precise control over the manufacturing method of the gears. That's why the gears are costlier. The error in cutting teeth may cause vibrations and noise during the operation. As we know that in case of gears, the two teeth are coming in contact with each other. They are coming in contact with each other. And when there is chances of backlash in the gear tooths, then there is a chances of vibration and the noise during the operation. Now, as the two elements are coming in contact, we need the suitable lubrication is necessary for the operation of the gear drive, because two teeth are coming in contact while transmitting the power from one shaft to the another shaft. That means when these two teeth are coming in contact, at that time we have to provide a proper lubrication to have a vibration free, noise free, friction free operation of a gear drive. So these are the some advantages and disadvantages of having gear drives. Now let's move to the classification of the gears. How the gears are classified. Now first basic point or basic criteria for the classification of the gear is according to the position of axis of shaft. As we have discussed that we are using gears to transmit the power between the two shafts, then it is necessary to know the alignment of shaft. That means the position of the axis of the shafts. So depending upon the position of the axis of the shaft, because we know that we are mounting that gears on the shaft, we are engaging that gears with the shaft. So it is necessary to know what are the position of the axis of two shafts. In between we have to transmit the power by using a gear drive. So depending upon that, the gears are classified. First, if the axis is parallel, means if the axis of two shafts between which we are transmitting the power or between on which the gears are mounted, if that axis are parallel and coplanar shafts connected by the gear is shown in diagram. Now these are the parallel axis. These are the parallel axis. These are the parallel axis. Again, we can see here in case of gear, these are the parallel axis. This is one of the axis. This is another axis. This is one axis. This is another axis. So these are the parallel axis. If this case is there, if the axis of the two shafts is parallel with each other, then this type of gearing is known as the spur gearing. These are known as the spur gears, in which the axis of the shaft is parallel, between which we have to transmit the power or on which the gears are mounted. If that is the case, then these type of gears are known as the spur gears. This is one gear, that is the driver, and this is the follower. The axis of both the gears or shaft is parallel with each other, coplanar and parallel. That is known as the spur gear. If the axis of the two shafts are parallel and coplanar, these are known as the spur gears, and the arrangement is known as the spur gearing. Now in this case also, these gears have the teeth parallel to the axis of the wheel. Look at this. These gears have the teeth. These are the teeth of the gear. These teeth are parallel to the axis of the shaft. The teeth of the gears or toothed wheels are parallel. This is the axis of the teeth. This is the shaft axis. This teeth axis is parallel to the axis of the shaft in case of the spur gearing. Another name given to the spur gearing is known as the helical gearing. Now this is another type of the spur gear, that is the helical gearing, in which the teeth are inclined to the axis. Look at this. These teeth are inclined. These are the two spur gears. This is the one axis. This is another axis. The axes are parallel. Now these teeth are inclined to the axis of the shaft. This is also a type of a spur gear in which the two shafts are parallel. But in this case, we have seen its teeth are parallel to the axis of shaft. But in this case, the teeth are, look at these teeth. These teeth are inclined to the axis of shaft. These teeth are inclined to the axis of shaft. These are known as the helical gears. These are known as the helical gears. Now in this case, there are also the single and double helical gears connecting parallel shafts are shown in figure. Now this is double helical gear because there is a two helix are there which are inclined to the axis of the shaft. The object of the double helical, this is the double helical gear and this is the single helical gear. This is also helical gear and this is also helical gear. Now this is a single helical gear and this is a double helical gear. The object of the double helical gear is to balance out the end thrust that are induced in a single helical gear. Due to the transmission of load, there is a possibility of end thrust might be get induced in a single helical gear. So to avoid this effect of thrust load, we are using the double helical gears. The double helical gears are shown also known as the herringbone gears. These are also known as the herringbone gears. Once again, try to understand. The spur gears are known as the gears in which axes are parallel, shaft axes are parallel with each other, that is known as the spur gear. In there we can again divide subtypes. If the axis of teeth and axis of shaft is same, it is known as the simple spur gear. If the teeth are inclined, only single teeth are inclined to the axis, then it is known as the helical gears. And if it has double helical gears, then it is known as the herringbone gears. These are the helical gears, these are the herringbone gears, and these are the spur gears. In these all three categories, the axis of the shaft is parallel with each other, between which we have to transmit the power. This is first classification depending upon the axis in which the axis is parallel. The next is intersecting. The two non-parallel, now this is one axis and this is another axis. The two non-parallel or intersecting, but these axes are intersecting at this point. This is one of the axis of the gear and this is another axis of the gear. Now these two axes are not parallel to each other. This is one axis and this is another axis. These two axes are not parallel to each other, but these are intersecting. These axes are intersecting. But coplanar shafts connected by gear. It is a coplanar, it means in one plane. These gears are called bevel gears and the arrangement known as the bevel gearing. If the axis of two shafts on which we have mounted the gear, or axis of two shafts between which we have to transmit the power, if these two axes are not parallel with each other but these are intersecting, but these axes are intersecting and it is in one plane, these axes are in one plane, then this type of gearing is known as the bevel gearing. The bevel gears, like spur gears, may also have their teeth inclined to the face of the bevel. These teeth may be inclined to the face of the bevel. That is known as the helical bevel gears. These are known as the simple bevel gears, in which the axis of the shaft is non-parallel but it is intersecting. This is another classification of gears depending upon the position of axis. First we have seen the position of axis is parallel. Second we are looking at the position of axis is non-parallel but intersecting. These are known as the bevel gears. The third classification depending upon the position of axis is the non-intersecting, non-parallel. This is one axis and this is another axis. These two axes are non-parallel, non-intersecting. The two non-intersecting, non-parallel, that is non-coplanar shafts, if connected by gear, then these gears are known as the skew bevel gears or spiral gears. If the axes are non-intersecting and non-parallel, these two axes, this is the one of the axis and this is the another axis. If these two axes are non-parallel and non-intersecting, these two axes are non-parallel and non-intersecting, then it is also then this type of gear is known as the spiral gear, or it is also known as the skew bevel gears. This is the third classification of gears depending upon the position of axis. First we have seen when the axes are parallel. In that category we have seen spur gear, single bevel gear, single helical gear and double helical gear. In second category we have seen if the shaft axes are non-parallel and intersecting, then these are known as the bevel gears. And in third category, if the axes are non-intersecting and non-parallel, then these are known as the skew gears, skew bevel gears or spiral gears. So these are the three subtypes depending upon the position of axis of shaft between which we have to transmit the power. This is the major classification, first major point, depending upon the position of axis of shaft. Now second basic criteria for classification of gear is the depending upon the velocity of the gear. Depending upon the velocity of the gear, how gears are classified depending upon the velocity of the gear. Now first classification is the low velocity. When we can say it is a low velocity gears? If the gears is having velocity less than 3 meter per second. If two gears get engaged and their velocity is less than 3 meter per second, then we can say these gears are low velocity gears. Second is the medium velocity. When the velocity of the gear is between 3 to 15 meter per second, then we can say that these are the medium velocity gears. And the velocity, if the velocity is more than 15 meter per second, then it is known as the high velocity or high speed gears. So second major classification is depending upon the velocity of the gears. Depending upon the velocity of the gears are classified as low velocity gears, medium velocity gears and high velocity gears. This is the second major classification. Now third major classification is depending upon the type of gearing, means how the gears are engaged with each other. That is the type of gearing. The first major classification we have seen depending upon the position of axis of shaft. Second major classification depending upon the peripheral velocity of the gear. And third major classification is the depending upon the type of gearing, means how the gears are engaged with each other. That is the type of gearing. Now depending upon the type of gearing, the gears are classified as first sub classification depending upon the type of gearing is first external gearing. In external, if the gears are engaged externally, that's why these are known as the external gearing. In external gearing, the gears means teeths, gears of the two shafts mesh, means intersect externally with each other as shown in a diagram. The larger of these two wheel is called as the spur wheel or spur gear, and the smaller wheel is called as the pinion, means gear and pinion, driver and follower. The larger gear out of two is known as the gear, larger wheel, and the smaller gear or smaller wheel is known as the pinion, gear and pinion. Keep in mind, if the two gears are engaging with each other externally, then the larger toothed wheel is known as the gear and the smaller toothed wheel is known as the pinion. That is the gear and pinion. This is the external gearing. Look at this. These gears are engaged with each other externally. Look at this. These are the gears. This is one gear. This is known as the gear and this is known as the pinion. This is the example of spur gear. The axis of shaft is parallel. This is a larger diameter toothed wheel. This is a smaller diameter toothed wheel. That's why this is known as the gear and this smaller one is known as the pinion. And these are engaging with each other externally. These are engaging with each other externally. If it rotates in clockwise direction, then pinion rotates in anti-clockwise direction. Keep in mind. Look at this. If gear rotates in clockwise direction, then pinion rotates in anti-clockwise direction. That means in external gearing, the direction of rotation is exactly opposite to each other. If gear rotates in, means driver rotates in clockwise direction, then pinion rotates in anti-clockwise direction. This is known as the external gearing. If the teeths or two gears are meshing with each other externally, that is known as the external gearing. Its best example is the spur gear. Now second is the internal gearing. In case of internal gearing, the gears of the two shafts mesh internally. Look at this. This is one gear and this is another gear. In both cases, the tooths of gear are meshing internally. Look at this. This is outer gear and this is inner gear. The teeth of this outer gear engaging with smaller gear internally. That's why these are known as the internal gears. The larger of these two wheel is called as the annular wheel. This is known as the annular wheel, and the smaller wheel is called as the pinion. If there is a case of internal gearing, means the tooths or teeth of the two gears are meshing with each other internally, then it is known as the internal gearing. In that case, the outer gear or larger gear is known as the annular wheel, and inner gear or smaller gear is known as the pinion. This is the example of the internal gearing. And depending upon the engagement of gearing, we are saying according to the type of gearing. Now in this case external meshing, in this case internal meshing, and third type is the rack and pinion. This is the third type, rack and pinion. This is second type, internal gearing, and this is first type, external gearing. External gearing, internal gearing, and rack and pinion. Now in case of rack and pinion, sometimes the gear of a shaft meshes or engage externally and internally with the gears in a straight line. Now in this case it is an external meshing. This is one gear and this is another gear. This is an external meshing, but in a straight line, with the gears in a straight line. Such type of gear is called as the rack and pinion. This straight line gear is called as the rack. This straight line gear is called as the rack, and this circular wheel is called as the pinion. A little consideration will show that with the help of rack and pinion, we can convert a linear motion. This is the linear motion. We can convert a linear motion into a rotary motion and vice versa. We can convert linear motion in rotary motion, or we can convert rotary motion in linear motion. If we are giving input power to the rack, then we are converting linear motion into rotary motion, and if we are giving input to the pinion, then we are converting rotary motion into the straight line motion or linear motion. This is the use of rack and pinion, to convert the linear motion in rotary motion and to convert the rotary motion in linear motion. So this is the third subtype of engagement of gearing, how the gears are engaged externally, internally, and if one gear is straight line and one is circular, it can mesh externally as well as internally. So in classification of gears, we have seen according to the position of axis of shaft. If the axis of shaft is parallel, then there are three gears are there: spur gear, single helical gear, and double helical gear. Then again type of axis depending upon the position of axis of shaft: non-parallel and intersecting. These are known as the bevel gears. Non-parallel and intersecting. Third subtype depending upon the position of axis of shaft: non-parallel, non-intersecting. Non-parallel, non-intersecting. These are known as the spiral gears. This is the first major classification. Second major classification depending upon the velocity of gear. In that sub classification: low velocity if velocity less than 3, medium if the velocity in between 3 to 15 meter per second, and high velocity gearing if the velocity is more than 15 meter per second. And third major classification depending upon the type of gearing, means how the gears get meshed, how the gears get engaged with each other. In that case, we have classified gears as first external gearing if the teeths or gears are meshing externally, that is external gearing. Second, internal gearing, if the gears of the two shafts mesh internally. And third type is the rack and pinion, when there is a straight line motion is transmitted in the rotary motion. So this is the basic classification of gears, how gears are classified depending upon position of axis of shaft, depending upon the velocity of transmission or peripheral velocity, and third depending upon the gearing, means engagement of teeths. So this is regarding the classification of gears. I hope you have understood how gears are basically classified. Thank you.